All right. So, number one, whenever we have a variable, it is to the first power, so we can put a 1 there. When we're multiplying, we simply do keep the base and add the exponents. 7 plus 1 plus 4 is 12, so that's a to the 12th. That's a mess. Let's try that again. A to the 12th. All right, on this one, remember, the numbers are still just 3 times 7, so that's simply 21. The x's, though, we have to add the exponents. The problem is 2/3 and 4/7 can't be added. We have to find a common denominator. That will be 21. Just come off to the side. 3 times 7, 2 times 7. 7 times 3, 4 times 3. And that gives us x to the 26 21sts. That's a little 6 there. And the y just tags along. All right? Here, remember the 5 has a 1. So we take the 3 times 1, 5 to the 3rd. 3 times 4, a to the 12th. And 5 to the 3rd is 125. We are finished. Now, here, it's just a simple basic fraction. 6 over 2. That's 3. Okay? The y's, there's a couple ways to look at this. Technically, you're supposed to subtract. So 3/5 minus 3/5 is y to the 0. Anything to the 0 power is 1. Another way to look at it is anything divided by itself is simply 1. So there's your answer. Now, number 5. I'm going to actually come off to another page and come back to it because there's just too much to do to show you to fit in this page. So I'm going to come off to do this one. So we have 28 x to the 8th, y to the negative 7, all over negative 4, x to the 12th, y to the 6th. Now, it's all taking the negative 2 power. Before you take 28 and negative to negative 2 and negative 4 to negative 2, how about we just simplify this to make our life easier? You don't want to square 28, do you? No. So that is simply negative 7. So this is going to be negative 7 to the negative 2. X to the 8 times negative 2 is negative 16. Y, negative 7 times negative 2 is positive 14. X, 12 times negative 2 is negative 24. Y, 6 times negative 2 is negative 12. Because that negative 2 has to go to everything. Now, remember, negative exponents, my mistake, sorry, this was negative 7 to the negative 2. I know I said it, but I didn't write it. Now, be careful when you type this in because it's negative 7. You use parentheses on your calculator. Just remember it will always be positive. Since it has a negative exponent, it is going to go down in the basement, downstairs. So that's going to be negative 7 squared, which is 49. The x's. X to the negative 16 goes downstairs. Y to the 14 stays upstairs because it's positive. X to the 24. That goes upstairs. Y to the negative 12. That goes upstairs. Okay? So then when we clean it up, where do I have more x's? On the top. How many more? 8 more. Y's, 14 plus 12, that's 26. And 49 on the bottom. Okay? So again, that's x to the 8 times y to the 26 over 49. All right, 3/2. This is a 1. The 3/2 is going to go here, here, and here. So that's going to be 16 to the 3/2. X, 4/3 times 3/2. 3's cancel. 2 goes into 4 2 times. Boom. Y, 6 times 3 is 18, divided by 2 is 9. And now, you can type this into your calculator All right? Or you can take the square root of 16, which is 4, and cube it, which is 64. Doesn't matter. A lot of different ways to do this. Number 7. Remember here, you start off by just worrying about the numbers. 7 times 8 is simply 56. Keep the base, add the exponent. So we need to add 3/4 and 2/7. So I need a common denominator, 28. 4 times 7, 3 times 7. 7 times 4, 2 times 4. Add them up. It's going to be 29 28ths. That's it. Okay, number 8. This is no different than if we had x to the 5th, x to the 7th over x to the 10th. Keep the base and add the exponents. X to the 12 over x to the 10. Where do I have more? On top. How many more? 2. It's the same thing with the 4s. It doesn't matter whether it's a number or letter. This is going to be 4 to the 12th over 4 to the 10. So that's going to be 4 squared, which is 16. Number 9 is easy because the entire quantity here is raised to the 0 power. So it's just 1. Number 10. So number 10, first off, again, go back to grade school. If you had -5 over 20, all right, you would simply reduce that to -1/4. It's going to be the same thing here. We're going to start off and put the 4 down here. The negative can go top, bottom, doesn't matter. Now, look at your letters. C to the -4, that's going to go downstairs. D to the 6th is going to stay upstairs. C to the 3rd is going to stay downstairs. D to the 5th is going to go upstairs. And what we end up with is D to the 11th over C to the 7th, and the negative can go anywhere. Outside, top, bottom, doesn't matter. Just make sure it's negative. Okay. Number 11, remember the 6 has a 1. Whoops, 1. So the 4 goes to everything. So that's -6. Careful. Put in parentheses, because if you type it in the calculator and put -6 to the 4th, you'll get a negative number. And it's supposed to be positive. X, 3 times 4 is 12. Y, -2 times 4 is -8. So -6 to the 4th power is 1296. The X stays upstairs. The Y moves downstairs to get positive. And that's our answer. This is a 1 here. -8 to the 1/3, or the cube root of the -8. X, 9 divided by 3 is 3. Y, 12 divided by 3 is 4. Only thing to do here is clean it up. -2, x to the 3rd, y to the 4th. Okay, on number 13, notice the difference between 13 and 14. On 13, the parentheses, there is no parentheses, and the 5/2 just goes with the x. On 14, the 13 and y are in parentheses. So the most common mistake, I'm going to write it here, the most common wrong answer is this. That's wrong. Don't do that. That's what you do for 14. For 13, the 7 stays outside. Okay. Now on 14, the entire 13y goes under the radical. That's a 3 there. Let me clean that up a little bit. That's a 3 there, 7 there. Number 15, again, the 2 is outside. Here's my radical, cube root. You don't even need the 1 there. That's it. Number 16, notice this is a square root. 17 is a square root. 13 is a cube root. So for square roots, remember you're looking for numbers like 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, 169, 196, and so forth, 225. Okay? For cubes, you're looking for numbers like 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. All right? You should have these written down, and they're a good reference for when you're taking the test. You can use the chart. So for 16, don't forget this 5 is out here. If you need to bring it out to remind yourself, 5 times whatever comes out. Now you look at the list. Now, even though 4 goes into 32, you want to work backwards to find the biggest number possible, and that's 16 times 2. When the 16 comes out, the square root of 16 is 4, that's going to multiply by the 5. But the radical 2 is going to be stuck inside. Leave a space for the letters. Now k, you have a couple choices here. You can write out 5 k's and then circle groups of 2. And say that is k squared with 1 k left inside. The other thing is you can just do 5 divided by 2. That's going to be 2, remainder 1. Whatever works for you. And the m's easy because that's 12 divided by 2 is 6. So clean it up. 20 k squared m to the 6th times the square root of 2k. Final answer. Number 17. 4 and 3. Don't forget about this negative 3. Square root of 4 is 2. The 3 is going to be over here. X, 5 divided by 2 is 2 with 1 left over. Y, 6 divided by 2 is 3, no leftovers. Z, 9 divided by 2 is 4 with 1 left over. Clean it up. Negative 6, x squared, y cubed, z to the 4th, times the square root of 3x squared. Sorry, that's not a squared. I can't read my own writing. That's xz. Sorry about that. Okay, number 18, we're looking for cube numbers. So what goes into this is 27 and 2, but notice it's negative. We can deal with negative cubes. We can't deal with negative squares, square roots. Okay, we can do negative cube root. Eventually in this quarter, we will learn how to deal with negative square roots also, but not right now. So the negative goes with 27 to come out as a negative 3. The 2 is going to stay inside. Now x, 5 divided by 3 is 1 with 2 left over. Y, 11 divided by 3 is 3 with 2 left over. And that's really the answer right there. Nothing to clean up. All right, number 19. Okay, again, pay attention. This is a cube root. The 3 is going to be waiting outside. 8 and 5 are the numbers we're going to use. The cube root of 8 is 2, so that comes out. The cube root of 5 stays inside. M, 3 divided by 3 is 1. N, 4 divided by 3 is 1 with 1 stuck inside. So my final answer is 6mn cube root of 5n. Now number 20, we're going to distribute. This is no different than if I was doing 2x times 3x minus 2y. I mean, some finer details in finishing up, but the math is still the same. I do number times number, which is 6. Instead of doing x times x and getting x squared, I'm going to get radical 10 times radical 10. Now, one way to do that is to say it's radical 100. And then come down here next and do 6 times 10. Some people will go right to this because a radical times itself is just what's ever under the radical. So radical x times radical x is simply x. Radical 7 times radical 7 is simply 7. So it's up to you whether you want to take the step of doing the square root of 100 or just go right to 10. Minus 2 times 2 is 4. And radical 10 times radical 6 is radical 60. Now here's the thing. Radical 60 can break down into 4 and 15. So minus 4 times square root of 4 is 2. And the radical 15 stays inside. Clean it up. This is 60 minus 8 radical 15. Final answer. Okay, off the bat, 21, you cannot combine them because they're not the same radicals. But if we simplify them, maybe they will be. So, 98 breaks down to 49 and 2. 72 breaks down to 36 and 2. It's going to work out. Don't forget about these guys. So 5 times the square root of 49 is 7. Radical 2. Minus 2 times square root of 36, which is 6, is 12. And the radical 2. I can put these together. This is 35. So 35 minus 12 is 23 radical 2. Again, just the numbers times the numbers on the outside is 21. Radical 2 times radical 20 is radical 40. Sorry. And it's not square root radical, it's a cube root. Sorry. Come on. Little 3 here. That's very important because I don't want to do 4 times 10 because I'm looking for cube roots. So that's 8 and 5. So the cube root of 8 is 2. So I have 21 times 2 times the cube root of 5. So that's 42 times the cube root of 5. Don't forget to put that little 3 there. It's very important. Okay, next. If you multiply 12 times 16, okay, hold on, you get 192. Okay, so cube root of 12 times the cube root of 16 is a cube root of 192. Now we got to look and see which of those magic cube numbers goes into that. All right, and so, hold on, do some division in your calculator, and you find out that it's 64 and 3. All right, now, cube root of 64 is 4. And the cube root of 3 stays inside. Number 24. We cannot have a radical on the bottom, so we need to rationalize, multiply by radical 3 over radical 3. On the top, that simply gives us 15 radical 3. On the bottom, again, if you need to go to radical 9 and 3, or just straight to 3, it's up to you. Then you're going to simplify and get 5 square root of 3. Number 25. Again, we cannot have the radical 7 on the bottom, so we multiply by top and bottom radical 7. On the top, that's going to give me 3 radical 56. On the bottom, I'm going to get just 7. But again, 56 can break down, all right, 4 times 14. The square root of 4 is 2, so 2 times 3 is 6. Square root of 14, and 7 on the bottom. For this one, again, multiply it by radical 5 over radical 5. On the bottom, I'll simply get 5. On the top, so get a radical, I get 120. Well, that's 4 times 30. Square root of 4 is 2. Square root of 30 stays over 5. Now, I want to show you something. Let's say this was radical 20 over radical 5. You do not have to spend time rationalizing, because 20 divided by 5 is 4. Therefore, radical 20 divided by radical 5 is radical 4, which is 2. You can divide radicals. You can reduce by the same radical number, just like regular numbers. It will save you time. All right, number 27. This is going to break down to 64 and 2 and 1,002. Perfect cube, perfect cube. So the cube root of 64 is 4. Cube root of 2. Cube root of 100 is 10, but don't forget about this negative 5. So negative 50, cube root of 2. 4 of these things, take away 50 of these things, is minus 46, negative 46, cube root of 2. Final answer. Number 28, again, like above, we're going to multiply each one. Outside times outside, 2 times 4 is 8. Radical 3 times radical 2 is radical 6. 2 times 5, outside times outside is 10. Radical 9, or simply 3. It's up to you what you want to do. And this ends up being 8 radical 6 plus 30. Final answer. Okay, 29 and 30, just take a lot of work. Okay? Just slow and steady. Don't be in a rush. Take your time. There's a lot to pay attention to. First off, there is stuff on the outside you cannot forget about. Okay? So if you want to write those down here, just to get them out of the way, just to remind yourself they're there, space it out, that's fine. Now, 108, we need to break this down, okay, into perfect cube numbers that go into 108. This one is 27 and 4. Okay. Next one, 320, is 64 and 5. And 32 is 8 and 4. Now, these are all cube roots, remember? So, the 27, cube root of 27, first off, is 3. I'm going to put that in front of the number. Now, I have to deal with this. 3 divided by 3 is 1, so that's going to come out. What's left inside is the cube root of 4. Next one. The cube root of 64 is 4. So I'm going to put plus 4 and put the number in front of the variable. 6 divided by 3 is 2. And the cube root of 5 stays. On this last one, cube root of 8 is 2. So 2 times 2. 9 divided by 3 is x to the 3. And the cube root of 4, right here, stays inside. Now, slowly clean it up. This ends up being 3x cubed times the cube root of 4. This ends up being 4x cubed, but cube root of 5. Not the same. I know they both have x cubes on the outside, but they're different radicals. Plus 4x cubed, cube root of 4. this one and this one will join together, which gives me 7x cubed times the cube root of 4 plus 4x cubed times the cube root of 5. Final answer. You just got to take it slowly. All right, last one on this page, last one of these kind of messy ones. Take your time. 4x, I'm going to write it here. Negative 8x squared, I'm going to write it here. Plus 6x squared, I'm going to write it here. Because, or sorry, 6x cubed. Because there's a lot going on, I don't want to lose anything. So, 432. Again, I'm looking for cube roots. Okay? So that's 216 times 2. This time I'm going to do it differently. I'm going to work one by one. See if that approach is better for you. So, the cube root of 216 is 6. So I'm just going to put that 6 out here. 6 times 4. I'm going to have the cube root of 2 just sitting here, waiting. Now the x's, 9 divided by 3, I'm going to bring on another x to the third. Remember, this is x to the 1. That one's done. Now this one, 40, that's going to be 8 and 5. So the cube root of 8 is 2. So I'm just going to put a little parentheses 2 there to remind myself to multiply. And then cube root of 5 is just going to be stuck inside. Then my x's. 6 divided by 3 is x squared again. Last one. This is 125 times 2. 125, cube root of that is 5. So I'm just going to put it here in parentheses to remind myself to multiply. I'm going to put the cube root of 2 right here. 3 divided by 3 is x to the 1. Now let's clean it up. This is 24, x to the 4th, cube root of 2. This is minus 8 times 2 is 16, x to the 4 also, but cube root of 5. Plus 6 times 5 is 30, x to the 4, cube root of 2. And again, only these two go together. They have to have the same radical. So that's going to be 54, x to the 4th, times the cube root of 2, minus 16, x to the 4th, cube root of 5. That's it. Now on this page, we don't have to do 31 to 33. We skipped that in class. Let's move on. Now, some of you are going to look at number 34 and go, well, if I just multiply by radical 3 over radical 3, don't do this, I'm done. But you're going to be playing whack-a-mole. Because when you multiply the bottom by radical 3, this radical will go away. But then over here, you'll have 2 radical 3. And if you do it again, this one will go away and it'll come over here. And I'll just keep going, bouncing back and forth like whack-a-mole, and you'll never get rid of it. We have to multiply by the conjugate. Think back to when we used to do x plus 5, x minus 5. And we'd multiply that and get x squared plus 5x minus 5x minus 25. The insides canceled out and we got x squared minus 25. Very important. The difference of two squares. Or we learn how to factor that into this. The same thing, 1 plus 1 minus. Basically the same concept as a conjugate. So, we're going to apply the same idea here. Remember, the conjugate is the exact same thing except opposite sign. So the conjugate of 2 minus radical 3 is simply 2 plus radical 3. Top and bottom. Now, we're going to distribute the 3 both places. So 6 plus simply 3 radical 3. Now on the bottom, when I FOIL or double distribute or whatever you call it, I'm going to do 2 times 2 and to get 4. And on the outside inside, I'm going to get plus 2 radical 3 minus 2 radical 3, which you're going to cancel. And the very important part, like I said before, is the minus. Negative radical 3 times positive radical 3 is negative radical 9, or simply just 3. You must end up with subtraction in the bottom, or you did it wrong. Well, 4 minus 3 is 1, so that leads me to simply 6 plus 3 radical 3, and I'm done. So in 35, same concept, except this time the conjugate is 2 minus radical 7. 2 minus radical 7. When I multiply on the top, it's simple distribution. 5 times 2 is 10, minus 5. Just plop it in front of the radical 7. Now, this time I'm going to do a shortcut. Instead of doing the outside and inside, okay, I'm just going to do first and last, Florida, because they're going to drop out anyway. So 2 times 2 is 4. Don't forget the minus. And then radical 7 times itself is simply 7. And so on the top, I end up with 10 minus 5, radical 7. And on the bottom, I end up with negative 3. And that's my final answer. Done. Moving on. Important thing here is to make sure you check for extraneous solutions. You got to make sure they work. Okay? Now, people all the time on 36 want to square right away. You can't do that until this is by itself. We need to get rid of the 7 by subtraction, which gives us square root of x minus 1 equals 8. Now we square both sides. That gets rid of the radical. I end up with x minus 1 equals 64. Add 1 to both sides. I think I'm done, but I need to go up here and check and make sure, real quickly, in my head even. 65 minus 1 is 64. Square root of 64 is 8. 8 plus 7 is 15. Check. I have a good answer. 37 is actually easy because when I move the 9 over, I end up with this. And I cannot say the square root of a number is negative, so therefore it's simply no solution. Okay, a little bit more going on here. Now think about this. This is not really more complicated than 4x plus 6 equals 34. I just made this the same thing as x. Well, what would I do there? I would subtract the 6 and divide by 4. Guess what? Same thing I'm going to do here. Subtract the 6. So this stays, equals 34 minus 6, which is 28. Now I divide by 4, just like I would have if it was an x instead of a radical. So I get the square root of 2x minus 5 equals 7. Now I'm just like the previous problem. Square, square. 2x minus 5 equals 49. Add 5. Sorry. Then divide by 2, I get 27. I needed to go up here and check it real quick. 2 times 27 is 54. 54 minus 5 is 49. Square root of 49 is 7. 7 times 4 is 8. 8 plus 6, 28 plus 6 is 34. Good answer. Okay, I'm telling you right now, there will be one like this on the test, number 39. You have to be able to do this. So this is going to be x squared and that radical squared. You've got to get rid of this radical. That gives me x squared equals 18 minus 7x. Always keep this positive. So move these two over there. So that's going to be x squared plus 7x minus 18 equals 0. All right? So when we talked about factoring earlier on, it's very important to be able to do this. This is a very basic factoring. I need two numbers that multiply give me 18. That differ by 7. 2 and 9. Now, since I want more leftover positives, I have to get that and that. Positive 9 x minus 2, x plus 9. When I set these both equal to 0, I get x equals 2 and x equals negative 9. I have to check my answers. So I plug 2 in up top. 2 squared is 4. 18. Sorry, I didn't look all the way up at the problem. I gotta look at the original problem. So, plug it in the original problem. Plug in 2. I get 2 equals the square root of 18 minus 7 times 2, which is 14. Well, that's 2 equals the square root of 4, which is 2. So 2 is a good answer. X equals 2. When I plug negative 9 in, negative 9 equals the square root of 18 minus 7 times negative 9. So that's going to be 9 times 7 is 63. So that's going to be plus 63. So that's going to be negative 9 equals the square root of 81. Well, square root of 81 is not negative 9. It's positive 9. So this is wrong. This is extraneous. You have to be able to tell me extraneous. There's going to be one on the test that's going to ask you whether it's extraneous or not. Hint, hint. There's a good chance there will be. Okay, 40. More practice. Square this side, square this side. That goes away. 12x minus 36 equals x squared. Again, leave this positive. So we're going to move these two over. X squared minus 12x plus 36 equals 0. I need two numbers that multiply give me 36 that add up to negative 12. So that's going to be minus 6 minus 6. So that leaves me to one answer, 6. It's the same thing. So if I plug that back in real quickly, 12 times 6 is 72 minus 36 equals 6. Well, 72 minus 36 is 36. The square root is 6. Check. Good answer. All right. I need you to recognize here that this is the same thing as this. And some people prefer to work with it like on the right. Some prefer it like on the left. I'll show both. Either way, we need to get this and this by itself. So we got to get rid of the 7 first. So 6x to the 1/3 subtract 7 equals negative 54. Same thing here. It just would look like this. 6 cubed root of x equals negative 54. Now I got to get rid of the 6. So I divide. X to the 1/3 equals negative 9. Same thing here. Except it's going to be the cubed root of x equals negative 9. Now, there's two ways to look at this. If I have it as an exponent, I want the reciprocal, which is 3. Or a cube root. Either way, I end up with x equals negative 729. If I plug that back in, the cube root of negative 729 is negative 9. Times 6 is negative 54. Plus 7 is negative 47. I have a good answer. All right, again, you could look at this as square root of x minus 5 equals negative 2. It's up to you. Okay? So first thing to do is get rid of the 5, negative 5, by addition. So that's going to give me 3x to the 1/2 equals 3. Or 3 square root of x equals 3. Divide by 3. X to the 1/2 equals 1. Square root of x equals 1. Reciprocal of 1/2 is 2. Squaring undoes square rooting. Either way, I end up with 1. Plug it back in. Square root of 1 is 1. 1 times 3 is 3. 3 minus 5 is negative 2. Good answer. All right. Number 43. Again, like earlier, before you start distributing this negative 4, how about reducing? Make it easier on yourself. It's 2. 4 over 8 is 1/2. You don't have to put the 1 on top. There's going to be plenty of stuff there. So distribute this negative 4 everywhere. It gets kind of messy, but you know what I'm doing. So x, negative 4 times negative 2 is positive 8. 4 times negative 4 is negative 16. On the bottom, x, 7 times negative 4 is negative 28. Negative 4 times negative 3 is positive 12. Clean it up. On the top, x to the 8 stays, it's positive. Y to the negative 16 goes downstairs to get positive. 2 stays on the bottom. X to the negative 28 moves upstairs to get positive. Y to the 12 stays downstairs, positive. But I did forget something. I forgot to distribute the negative 4 right here. Silly me. Which does mean this is going to move up top like so. Okay? Because I forgot to put that little 1 there to remind myself to distribute the negative 4 to the 2. It happens. Don't worry about it. So on the top I have 16. X to the 34. Keep the base, add the exponents. Y to the 28. Keep the base, add the exponents. Final answer. And look at that. We're finished.